we're going to be doing probability, and we're going to be focusing on the sample space of a probability. So in this lesson, you'll learn how to find the sample space for an event. So the first problem we're going to look at is Kelly's mom is expecting twins. The family wants to be surprised about the gender of the babies. Represent the sample space showing all possible outcomes. Well, first off, let's just answer some questions. So it says, if one of the babies is a girl, what are the possible outcomes of the other baby? Well, if one's a girl, the other one can be a girl or a boy. Okay, well, if one of the babies is a boy, what's the possible outcome of the other baby? Well, the other baby can be a girl or a boy. The first outcome does not affect the second outcome. So we're going to complete this table. Well, my first baby can be a boy-boy, boy-girl, or boy-girl, or girl-girl. So how many possible outcomes are there? Well, there's 4 possible outcomes. So it says, out of all the possible outcomes, how many are 2 girls? Well, there's only 1 girl, and there's only 1 boy. So list all the sample space of the possible outcomes. Well, you have a boy, a girl, a boy, or a girl, boy. It doesn't matter. These two represent the same. These two represent the same thing. Okay. Okay. So let's find out more. Well, one way we can represent this possible outcomes is actually representing it by a tree diagram. So we're going to draw a tree diagram to show the sample space of possible outcomes of a family with 4 kids. Well, their first kid can be a boy or a girl. Their second kid can be a boy or a girl. So this is right here is the first kid. This is the option for the second kid. So we got to branch it out again. This is their third kid, and we got to branch it out one more time. Lost track. My girl's supposed to go down there. It gets a little congested. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, I believe. Two, 4, 6, 8, 10, 12, 14, 16. So I think there should be, there's just 4 kids. So there's 16 possible outcomes. The way you do it is you just count the very end. And it'd be better if you could, draw your tree a little bit better on mine. Doing it on the computer is a little bit difficult. So this is your opportunity for your first kid, second kid, third kid, 4 kids. So these are all the possible outcomes for all 4 kids. Like you can have a boy, girl, or you can have a mixture of boy, girl, boy, girl, things like that. This just shows you all the possible outcomes. So there's 16 possible outcomes. So Charlotte is playing a board game. To move her game piece, she needs to roll the same number on 2 number cubes. So represent the sample space and find all the ways Charlotte could roll the same number cube. Well, on a number cube, which is just a dice, you can roll a 1, 2, 3, 4, 5, 6. So this is your first roll. Well, from that first roll, you roll another 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Because this represents your second roll. So there's a total of 36 possible outcomes. Okay? But the thing is, though, they want to get a roll with the same number. So the first roll and the second roll have to be the same. So this one is what they want. The 2 2s is what they want. The 3 3s is what they want. The 4 4s, the 5 5s, the 6 6. They represented this. They basically took this tree diagram and represented it as a model. The tree diagram is actually easier to create, but the model is easier to see. So when they want you to create a sample space, it's easier to create a tree diagram. But when you want to see it, a model, a table is easier because here's the 1 1, the 2 2, the 3 3, the 4 4, the 5 5, and the 6 6. So there's only 6 possible outcomes out of a total of 36 that you could win with this. Okay, so how does the tree diagram represent the sample space? How many outcomes are there? Well, as we said, there's 36. So it says it represents all the roles. So how many branches of the tree diagram represents rolling the same number on both cubes? 6 branches. So look at the table. List all the possible outcomes there are in the same number on both cubes. Well, there's 6 possible outcomes. 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6. So to move his game piece, Nathan needs to roll 2 even numbers. Are there more or fewer favorable outcomes? Well, there's always more because there's more outcomes for him because there's 3 even numbers on a dice. So it's easier to roll an even number than to get the same number. And we'll talk more about that in class. All right, represent a sample space of tossing a coin and rolling a cube. We have a heads and you have a tails. So each thing will have a 1, 2, 3, 4, 5, and 6. And then the tails will have a 1, 2, 3, 4, 5, and 6. Again, it's harder to do on the computer. So how many possible outcomes? Well, you just have to count here. Well, there's a 6 here and there's a 6 there, so there's 12 possible outcomes. How many times does a head and an even number appear? Well, this is the head, and there's 3 even numbers on here, so it occurs 3 times. All right, that's the main idea. Creating a sample space is pretty straightforward for probability. Okay, again, just watch the video, and I'm going to have 3 other videos later this week over probability. And this will be our last unit before the winter break. Okay? Thank you, guys.